So the number 3 problem is a trapezoid is defined by the points 0, 0, AH, BH, and C0. Find the area of the trapezoid. So basically, we have to derive here the area of a trapezoid because for the longest time in our lives, we know that the area of a trapezoid is b1 plus b2 times height over 2. It can also go by this form or this form, but we didn't really know the concept of that formula. So in this case, we are here to know the concept of that formula. So in this case, we are given points for 4 points that would form a trapezoid. 0, 0 at the origin, AH, BH, and C0. In order for the way for me to get AH and BH was to have another 2 points right here, which is A0, which is a value on the x-axis but not on the y-axis. B0 also a value on the x-axis, not on the y-axis. And these are in line with AH right here, but these two have a value on the y-axis, which is h, or the height of the trapezoid. The height of these two are congruent in this case, and that's why it forms a trapezoid. So the first thing we need to do here is to divide the trapezoid into 3 different partitions. So in this case, this would be the first part, this would be the second part, and this would be the third part. So the thing that I use here is vertical strips in order for me to get the area of each via integration. So in this case, we are focused on the values on the x-axis in order for us to get the lower and the upper limits. So in this case, 0 and a is a lower and upper limit respectively. And of course, the function of this would be, at first, we will find that later on, we just put fx of 1 for a while right here. We are focused more on the limits for now. So the limits for the second partition would be a and b, lower and upper respectively, and fx2 would be copied, and we have the last one would be lower limit of b, upper limit of c, and the function 3. So in this case, we have to find each of the functions right here. So we know that the basic or the standard equation for a line would be y is equal to mx plus b. We know that these are all lines here, and there are also lines here, 3 lines here, which is just equal to 0. So it won't really make our lives hard in this case because we can just neglect the 0. We can just choose not to subtract it from what we got earlier because it would just give us the same value. So in this case, we have to find each of the functions. So the function 1 would be equal to this partition right here. So we know that this is a line, and the way to get in y is equal to mx plus bm is the slope. In order for us to get bm, or the slope, we have the distance formula right here. So y2 minus y1 over x2 minus x1. So in this case, we designate this as x2, y2, and this is the x1, y1. So we have y2 minus y1, h minus 0, and a minus 0 times x. And of course, we know a while ago that b, of course, in the line, we have the b, which is the intercept or the initial position. And in this case, it's just 0, so we just not add it, neglect it. It would give us the same value anyway. So the second function would be this partition right here. So we know that this is a straight line, which is parallel to the x-axis. So we know that it wouldn't have a slope because it is a straight line. It has a slope of 0. If it was a vertical line, that would have been a slope of infinity. But we're not focused on the y-axis. We're only focused on the x-axis. So the slope of this is 0. So 0x would be 0, so we neglect that. So we just focus on its initial position. So in this case, we have h as its initial position right here. So we focus on the y's in this case. Yeah. So For the last partition, we have to get, yes, the last function. So we designate this as our y2, x2, y2, and this would be x1, y1. So if we think about it, we can just invert this triangle, and these would be in the form of like that. So basically, the formula for the slope of that would be the same as earlier, h minus 0 and b over b minus c, like this, in the distance formula that I just said a while ago. But for its initial position, that would have been subtracted by c, because if we are to think about it, it's positioned here, and the initial position is, yeah, c. It's a distance of c from its initial position. So that would be shown in the form x minus c. So in this case, we are now ready to plug this in. And if we actually add this, of course, we are to get the area of the trapezoid. So in this case, it goes by in this form right here. Now we integrate this x squared over 2, and yeah, it would be like this, with of course the same limits. H would be hx, and this would be distributed, and of course this c here would have an x, and this would be x squared right here over 2 with the same limits. So it goes by a process. You already know how to get the integrations of simple variables or simple terms. So in this case, we have to substitute now the lower limits and the upper limits in each. So x squared here would be a squared times h over 2a, and of course 0 squared would be 0. 0 on the numerator would cancel the entire term. So that would be a squared h over 2a, and that would give us ah over 2. Now h times b, hb minus ha, it's simply like this. In this case, I actually made it simplified, or quite simpler to actually like put the values in, because if we just have this substituted here minus this substituted here, then it would be like too long and too hard to simplify. So in this case, we can just take off because this is x squared right here, we can just put substitute the c here, c squared minus b squared, and just multiply it to the original, which is h over 2 b minus c. So this is like this in this form. Now we know from the concept of difference of two squares that c squared minus b squared is equal to c plus bc minus b. Now in this case, I put it in that way. So we cannot actually cancel something here, but if we get the negative 1 from this c minus b right here, that would be inverted, so that would become b minus c. So b minus c is equal to this one, so we can get the negative 1 from that and cancel this. So we are left now with h times c plus b minus 2, and of course the negative 1 that we just took away a while ago would affect the entire term. So in this case, the same process that I said a while ago, c would be substituted here, b would be substituted here separately. So in this case, c minus b, the original would be h c over b minus c, and x here is c in the first term and b in the second term, so that would be c minus b. So multiply that to this original right here, and you would actually get in order for us to actually simplify this further, we have to get the negative 1 of this once again in order for us to actually make it the same as this one right here, b minus c, because it's negative b plus c. So in this case, it becomes positive from negative, and we can cancel the b minus c, and we're left with plus hc. So now we add this, the 5 terms that we are left with. So in this case, AH over 2 and AH, they can be grouped together. So in this case, we have AH 1/2 of AH minus 1 of AH, that would be negative 1/2 of AH. BH minus 1/2 of BH, that would be 1/2 of BH. And CH or HC, that would be the same. Negative 1/2 of HC or CH plus 1 of it would become 1/2 of CH. So that would give us this. Now we can take away the common factors here. That would be 1/2 H. You can take that off. And we are left with C plus B minus A, or negative A plus B plus C. I just rearrange it for it to be efficient. And we are left with 1/2 H C plus, of course, we know a while ago I have shown the drawing to you a while ago, and the base 1 would be the total of B, 0 to B, minus the total of 0 to A. So that would be B minus A would be equal to the base 1. So in that case, we can just replace it with base 1 right here. And the base 2 would be the distance from 0 to C right here. So that would have become B2. So we can just actually have this as our final answer, because it already proves that we have added each of the areas of this using via integration, and we end up with this answer. So that would be all.